Hello everyone and welcome back to my channel. Today we're going to take a look at another math problem. This is from the 2017 Euclid contest, question 7a. Lynn is driving at 60 kilometers per hour on a long straight highway parallel to a train track. Every 10 minutes, she is passed by a train traveling in the same direction as she is. These trains depart from the station behind her every 3 minutes and all travel at the same constant speed. What is the constant speed of the trains in kilometers per hour? So of course, pause the video and try the question out for yourself. And let's get started. So you might have to really decipher the wording in this question because it does take a little bit to wrap your head around. But once you get an idea of what the question is saying, you can start mapping it out on paper. So over some distance, there is a division of a road and train tracks, over which the car goes on the road and the train goes on the tracks. It's saying that every 10 minutes, a train passes a car. For simplicity, let's just assume we start at the point when the train passes the car. The station is somewhere back here, but we don't need to worry about that because this is actually an endless loop. So it doesn't matter where we start because the loop will remain in the same pattern. So let's just call this the station back here. So from here, what do? Let's start off with our car and the train. It says in 10 minutes she's passed by the train. So because we're starting off with the train actually passing the car, we're going to make the car travel for 10 minutes. By this point, our first train would have already made it past over here, right? Because the train had passed the car from the start. So if the train had passed the car from the start, that means the train must be faster than the car, obviously. So after 10 minutes, the distance would have increased significantly. So we'll call this the 10-minute mark. The car traveled 10 minutes, some distance over 10 minutes. What about the trains though? It says that after the first train goes, the second train is then deployed after 3 minutes. So by around this point, the 3-minute mark, the second train has already left. So we'll call this T2, T1. Now the second train has just started T2. Because the first train has already passed the car, like we said before. Now T2 is starting at the 3-minute mark. So now we're saying that over the course of the next 7 minutes, the train T2 would have just reached the same distance as the car as it's about to be overtaken, right? Every 10 minutes it's overtaken, meaning it must overtake the car in 7 minutes, 10 minus 3. So the distance that the car travels in 10 minutes is what? Well, we know that the speed of the car is 60 kilometers per hour. So what is this in 10 minutes? Well, 10 is 1/6 of an hour. But actually there's a faster way to do this, because we know that an hour is 60 minutes. It's 1 kilometer per minute, right? So we're saying in 10 minutes, it's 10 kilometers. So the minutes to kilometers is actually a 1-to-1 ratio. So the car would have traveled 10 kilometers. Meaning that the train needs to travel 10 kilometers in this time frame, 7 minutes. Well, if the train covers that much distance in that much time, what is speed? It's distance over time. So the speed of the train, let's call it as S sub t, is going to be the distance over time. We have 2 t's, so we'll do capital T for time. and capital D for distance. So we sub in our values. The distance that we travel is the 10 kilometers. And the time that we do it, 7 minutes. So 10 kilometers in 7 minutes. We have to write it in hours. So it'll be something over 60 minutes because that's 1 hour. Call this value x. And x is going to be 60, we'll multiply both sides by 60 minutes, and then we get 600 kilometers every 7 minutes. Equals x. So the speed is then going to be 600 kilometers, 600 sevenths kilometer per hour. We can write it like this. And that is that question. Okay, and now for the 7b of the 2017 Euclid contest. This is a logarithm problem involving logs and radicals. Determine all pairs AB of real numbers that satisfy the following system of equations. Give your answer as pairs of simplified exact numbers. So of course, pause the video, try the question out for yourself, and then once you're done with it, you can unpause and let's go. Alright, so of course, the second equation, super easy to handle. Let's call this equation 1 and 2. Same base, we can actually multiply the arguments. So we're going to get log base 10 of AB equals 2. This is saying that the exponent we put on 10 is what we get AB. So 10 to the 2 must become our value AB. So 10 to the 2 equals AB. 100 equals AB. Okay, so that is our simplified version of equation 2. We can call it 3 in case we need the second one. What next? What do we do with equation 1? Well, you might think, okay, we can subtract root b from both sides and square it to get a and sub it in. But that takes way too long, and it's actually way harder. Instead, let's multiply both sides. At first, it's hard to see why we multiply both sides like this, but you have to notice that when you square something of 2 terms, you're going to get a middle term of AB, right? We know that AB is 100. So when we square 1, we're going to get a plus 2 root AB, because it's root a times root b, plus b equals 8 squared is 64. Sub in that AB is 100, and then we get 2 root 100, which is 2 times 10. So a plus b equals 64 minus 10 times 2 is 20. So a plus b is 44. So 2 numbers that add to 44 and multiply to 100. What does that sound like? Sounds like a quadratic. Of course, we're going to isolate one of these variables and sub it in, because now it's actually much cleaner. And then we're going to get 100 is equal to, if we isolate a, we'll get 44 minus b times b. And if we expand, 100 equals 44b minus b squared. And let's keep moving here. We get b squared minus 44b plus 100 equals 0. Is this factorable? 50 and 2, 25 and 4, 101. Doesn't look like it's factorable. So we gotta pull out the quadratic formula. Negative 44 plus or minus root b squared. 44 squared, what is that? 1936. And we have to subtract 400, so it's 1536. All over 2, because that is our a value, which is 1. And keep moving here. 1536 is 512 times 3. You would find that out by realizing that this number is actually a multiple of 3, because its numbers add up to a multiple of 3. Its numbers add up to 15. So 15 is a multiple of 3. So you can divide this by 3, and then when you divide it by 3, you get 512. So 512, what is that number? It looks like a nice number, right? We know 2 to the 10 is 1024. Divide that by 2, we get 512. So 2 to the 9 is 512. So we get 44 plus or minus the roots of 3 times 2 to the 9. And what does that become? I see 2 pairs of 2 to the 4, which is 16. And we divide that by 2, so it's 22 plus or minus 16 over 2 is 8. And we're left with a root 6. Okay, b is 22 plus or minus 8 root 6. And how do we get a? Well, if b is 22 plus 8 root 6, a must be 22. I guess you could say minus plus 8 root 6. So our pairs would then be of a, b, 22 plus, let's do minus first, minus 8 root 6, comma 22 plus 8 root 6. 22 plus 8 root 6, comma 22 minus 8 root 6. How did I know that they were almost symmetrical values in the signs? Because there are only 2 of the values. If you want, we can sub it into this equation 4, and we'll get 44 minus 22 plus 8 root 6, which is 22 minus 8 root 6. And then we'll get that these values are symmetrical. But since there are only 2 values, you know that I have to sum or subtract to each other, right? So that is that question.
Se la pasan diciendo que soy mala, porque no me aguanto drama de nada. Si vienes a mi cama, a mi cama.